Good evening. Welcome to Namssn Tutorial. This is MET 233. So my name is Kamal, and then we are looking at further differentiation and integration today. Well, this topic is not new. We've done it before while we were on what's it called, MET 122. So I'm going to start with the rules of differentiation. Well, so number one is a sum rule, sum and difference rule. Suppose we are differentiating two functions, u and v, either by sum or we are using a difference, is equals to du dx plus dv dx or minus. So whatever operation we are using here. Suppose we have y equals to 3x squared plus 5 plus 7x minus 1. So I want to differentiate these two functions with respect to their variables. So the variable here is x. Well, because of this sign, I will take the first one as my u, as you can see from the formula. So I will say let u equals to the first variable, 3x squared plus 5. And I will say let v equals to the other one, 7x minus 1. And you know that if I differentiate the first one with respect to x, if I differentiate 3x squared, so that's 3 times 2, 6x. And the derivative of a constant is 1. You know that one from elementary. And if I differentiate the other one with respect to x as well, differentiating 7x, that's 7. And if I differentiate 1, 1 is a constant, that one will be 0. So having done that, I'll just say dy dx equals to, this is du dx and this is dv dx. I will add two of them together. So dy dx equals to 6x plus 7. So that is how to apply sum and difference rule. Suppose what I have here is minus. Suppose what I have here is minus. I'll just say du dx minus the other one. So it will be minus. So whatever sign that we have here is what will determine what I'm going to do. So that's the answer. So the second rule is a product rule. So how does that one goes? Suppose I want to differentiate two functions whereby the operation between them is times, unlike the other one that the operation between them was plus. So if I want to differentiate two functions whereby the operation between them is times, it is the second one, the second function v multiplied by the derivative of the first function with respect to s plus, write the first one, differentiate the second one with respect to x. That is how product rule goes. So for example, let's say I want to differentiate y equals to x squared plus 3x times 3x raised to power 3 minus 5. So you observe that the operation here that bind these two functions together is times. So that's telling me that I'm going to use a product rule. So if what I have here is plus now, so it is sum rule, the other one that we did earlier. So I will say that let u equals to the first function x squared plus 3x, and let v equals to the second function 3x cubed minus 5. Then I'll take the derivative of two of them with respect to x, du dx. If I differentiate x squared, that's 2x. If I differentiate 3x, that's 3. And also I will differentiate the second function with respect to s. Differentiate 3x raised to power 3. This one will be 9x squared. Derivative of a constant is 0. So this is u, the first function. This is dv, this is v, and this is du. So it's just like I want to do cross multiplication, u and dv v and du, as simple as that. So du dx, sorry, dy dx, going by the formula v times du dx, this is v, this is du dx, that is 3x cubed minus 5 times 2x plus 3 v du plus u and dv 9x squared times x squared plus 3x. That is it. So if you see something like this in objective and the way they put the answer is different from what you get, so it is better to expand all the function and simplify them to the lowest term so that you get the answer that matches their own answer. So this is how to differentiate using product rule. So let's take another example. Example 2. Differentiate y equals to 7x minus 5, 8x raised to power 7 plus 3. So you see the operation between the two functions we are differentiating. This is times. Nothing is there. That's times. So the first function will be my u. Let u equals to 7x minus 5. The second one will be my v. Let v equals to 8x raised to power 7 plus 3. Differentiate each of them with respect to x. Differentiate 7x, that's 7. Differentiate 5, that's constant. And then you differentiate the other one too, dv dx. Differentiate 8x raised to power 7, that's 56 x raised to power 6. Differentiate 3. 3 is a constant, that's 0. So as I said earlier, product rule is just like you have two functions, just do something like this, cross multiplying. This is v, this is du, this is u, the other one here is dv. So as simple as that. So dy dx equals to v and du, that's 7 times 8x raised to power 7 plus 3 u multiplied by dv plus 56 x raised to power 6 multiplied by 7x minus 5. So if you expand and if you don't want to expand, so our answer is still the same. So the third rule, so is what we call chain rule, or sometimes they call it a function of a function. So the formula of chain rule is that dy dx equals to dy du times du dx. How do we apply this chain rule? Suppose we are asked to differentiate y equals to 3x minus 7 raised to power 4. Y equals to 3x minus 7 raised to power 4. You know, so it will be very cumbersome for me to go and expand 3x minus 7 all raised to power 4 and be differentiating them one by one. So there won't be time. So it is better I will employ this chain rule. So how am I going to do it? I will say let this function that I was given, let's call it u. Let u equals to this 3x minus 7. So if u equals to 3x minus 7, I will differentiate this u with respect to the variable that is here with respect to x. So du divided by dx is equals to differentiate 3x, that's 3, differentiate 7, that's constant. So after doing this transformation, this original function will now change to y equals to 3x minus 7 is u. This 3x minus 7 that is here. So 3x minus 7 is u raised to the power of 4. Then I will differentiate this y with respect to this variable u now. I'll call that one dy du. So if I differentiate y with respect to u, it means I'm differentiating this u raised to power 4 alone. That will give me 4 u raised to power 3. And according to the rule that we just said now, dy dx equals to dy du times du dx. So this is dy du in this context, and this is my du dx. So my final answer, dy dx equals to dy du multiplied by du dx. That will be, this is dy du, 4u raised to power 3 times du dx times 3. So 4 times 3, that's 12. So this one will be 12u raised to power 3. And then we recall that initially we represent 3x minus 7 by u. So we say recall that u equals to 3x minus 7. Recall that u equals to 3x minus 7. So our final answer, dy dx, equals to 12 into 3x minus 7 all raised to the power of 3. So that is the derivative of 3x minus 7 raised to the power of 4. So the number 4 rule is a quotient rule. By the word quotient, so whenever you hear quotient, it means that whenever we are differentiating a rational function, something that is like a fraction. Like if I want to differentiate a function like this u over v, fraction. So the formula is that v times du dx minus u times dv dx all over v squared. So this is the formula we are going to apply whenever I want to differentiate something like this. For example, let's differentiate y equals to x squared plus 5 over 3x minus 1, a function on another function. So the numerator, I'll call it u. I'll say let u equals to x squared plus 5, and the denominator, I'll take that one as v, and let v equals to 3x minus 1. So differentiate the first one with respect to s, du dx equals to 2x, and differentiate the second one too with respect to s, dv dx equals to 3. After that, plug in your values into this formula. So dy dx equals to v du. This is v, this is my du, that is 2x multiplied by 3x minus 1, minus, this is u, this is dv, 3 times x squared plus 5 all over v squared. This is v, 3x minus 1 all squared. So if I open the bracket, 2x times 3x, that's 6x squared. 2x times minus 1, that's minus 2x. Minus 3 times x squared, minus 3x squared. Minus 3 times 5 is minus 15. All over 3x minus 1 all squared. So collecting the like term, 6x squared minus 3x squared, that's 3x squared. Minus 2x minus 15 will just be there. Minus 2x minus 15 all over 3x minus 1 all squared. So that is the derivative of x squared plus 5 all over 3x minus 1 by using quotient rule. So the next aspect of differentiation that is very, very important to discuss is logarithmic differentiation. Well, so let me start with the elementary theory of logarithm. You know, if you have a log m raised to power n, so what will happen? Whenever logarithm has power like this, the power here will turn to coefficient. It will turn to n log m. And then, so let me list some table of derivative that I will be making reference to, although we are familiar with all these things in our Math 122, y and dy dx. You know, if y equals to s raised to power n, dy dx is ns raised to power n minus 1. If y equals to sine x, dy dx is cos x. If y equals to cos x, dy dx is minus sine x. If y equals to exponential s, dy dx is exponential s. If y equals to natural log of s, dy dx is 1 over x. So if y equals to tan x, dy dx equals to sec square x. if y equals to sec s, dy dx equals to sec s tan x. Okay, now, so you can pause the video and write that. Now let's start with this common derivative. Let's differentiate y equals to x raised to power x. Y equals to x raised to power s. So how do I move from here? X with power of x. So the first thing is to remove this power by taking the natural log of both sides. I'll say take the natural log of both sides. If I take the natural log of this side, I'll have ln y. If I take the natural log of this side, I'll have ln x raised to power x. Then ln y, according to what I said earlier, ln x raised to power s, this power s will turn to coefficient as x ln x. After that, I'll now differentiate both sides. So differentiate both sides. So if I differentiate ln y, that's 1 over y. And don't forget, I'm differentiating y with respect to x here. So I'll put dy dx. Remember implicit differentiation. Whenever you are differentiating y, you put dy dx with it. So if I want to differentiate this side, x and ln x, from our product rule, this x is a linear function and this ln x is a logarithm function. If I want to differentiate these two, I'll have to use product rule by taking the first one to be my u, the second one to be my v. Okay? And if you remember product rule, you write the second one, ln x, you differentiate the first one. If I differentiate x, that's 1. So it does not need, well, you can put 1. Plus, you write the second one, x, you differentiate the first one. The derivative of ln x is 1 over x. Okay? So 1 over y dy dx is equals to ln x plus 1. X cancel s. Then if you multiply both sides by y to remove this coefficient. So if I multiply both sides by y. So I will have dy dx equals to y multiplied by everything that is here, ln x plus 1. And recall that what is our y from the question? Y equals to what? X raised to power x. So anywhere we see y, change it back to x raised to power s. So our final answer is x raised to power s into bracket ln x plus 1. So the basis is that whenever you want to differentiate this kind of function, take the log of both sides, that log will linearize that function, and then you differentiate one after the other. So that is how to differentiate this kind of function. Let's differentiate y equals to x raised to power cos 2x. So x raised to power cos 2x. Well, the way it is like this is very complex. So we just take the natural log of both sides to make it more easier. So take the log of both sides. So if I take the log of this side, that's ln y. If I take the log of this side, ln x raised to power cos 2x. So this power will turn to coefficients. So I will have a ln y equals to cos 2x ln x. Now differentiate both sides. Differentiate both sides. If I differentiate ln, that's 1 over y times dy dx. So if I want to differentiate cos 2x and ln x, I'll use product rule because this is a trig function and this is a logarithm function. And what is product rule? This is u, the other one here is v. Write the second one, differentiate the first one. If I write this one, ln x, and I differentiate cos 2x. So don't forget your chain rule. If I want to differentiate cos 2x, that's 2 sine 2s with minus 2 sine 2s. So let me put it inside brackets like this. Plus, I'll write the second one, cos 2x. Differentiate the other one. If I differentiate ln x, that's 1 over x. So 1 over y dy dx equals to minus 2 ln x sine 2x plus cos 2x all over x. Now multiply through by y. So dy dx equals to y multiplied by minus 2 ln x sine 2x plus cos 2x all over x. So recall that what is our y? Y equals to what? X raised to power cos 2x. You put it back. So dy dx equals to x raised to power cos 2x into bracket minus 2 ln x sine 2x plus cos 2x divided by x. So that is how we differentiate this kind of function. Now let's differentiate y equals to 5x squared exponential 3x cos 2x divided by tan 7x squared. So look at this kind of complex function that we need to differentiate. So ordinarily, if I want to do it, I'll say, okay, I'm going to use quotient rule because I have a rational function. I'll differentiate the top and the bottom. But if I want to differentiate what is here, so I'll still have to use product rule. So we have multiple functions here. So it will be very difficult for me to use quotient rule directly. So the best way is to use logarithm approach. How am I going to do it? I'll take the natural log of both sides. So if I take the log of both sides, as usual, take the log of the left hand side, I will have log y. Don't forget from law of logarithm, if I have log a minus log b, it will equals to log a all over b. So by taking the logarithm of everything that is here, it will turn this fraction to log base e. Whenever you are seeing ln and log base e, they are the same. Log base e of 5x squared e raised to power 3x cos 2x minus log base e of tan 7x squared. Okay? So after that, from here, so you recall that whenever you see log a plus log b is equals to log ab. So this is log 5x squared times log exponential 3x times cos 2x. We can split this function too into different pairs of logarithm. So I'm going to have log y equals to log base e of 5x squared plus the other one, log base e of exponential 3x plus the third one, log base e of cos 2x minus the last one here, log base e of tan 7x squared. Okay? So after that, then I will take, well, is there anything that has power here? Yes, from here now, e raised to power 3x. So this power will turn to coefficients. So here I'm going to have log base e of 5x squared plus 3x log base e. You remember, log of the same base will equals to 1. So this one will cancel out. It will give us 1. Plus log base e of cos 2x minus log base e of tan 7x squared. Now differentiate. So if I now differentiate one after the other, differentiate ln y, that's 1 over y dy dx. Differentiate log base e of 5x squared. You remember the derivative of log is 1 over. So derivative of log base e of 5x squared, it will first be 1 over 5x squared times, now differentiate this 5x squared. If I differentiate 5x squared, that will give me 10x. Plus, what do I have left here? I have 3x here. If I differentiate 3x, that's 3. Plus, differentiate log base e of cos 2x. The derivative of log on its own is 1 over that cos 2x. Multiply by, you differentiate this cos 2x. If I differentiate cos 2x, that's minus 2 sine 2x. Minus the last one here, if I differentiate log, is 1 over that function, tan 7x squared. Multiply by, now if I differentiate tan, don't forget the derivative of tan is sec squared. Sec squared 7x squared. And I will also differentiate this 7x squared as well. If I differentiate 7x squared, that's 14x. 14x. So joining everything together, 5 here 1, 5 here 2, x cancel square, it will remain 1. So I will have 1 over y dy dx equals to, so we have 2 over x here plus 3. Don't forget, sine over cos is tan. Sine over cos is tan. So this one will be minus 2 tan 2x. 14 times 1, that's 14 x sec square x divided by tan 7x squared. So let me put everything inside a bracket like this, and the job is done. Clear the fraction, multiply through by y. So our final answer, dy dx equals to, I will multiply this one by y, right? And what is my y from the beginning? The whole thing here is my y. So dy dx equals to 5x squared e raised to power 3x cos 2x divided by tan 7x squared into big bracket 2 over x plus 3 minus 2 tan 2x minus 14x sec square x all over tangent of 7x squared. So that is how we differentiate any kind of function like this, that it is very hard for me to be differentiating one by one. So just introduce logarithm and it will make everything easy. So that is it. You can pause the video and watch it again. So from here, we use sine over cos. Sine over cos is tan. You know that one from elementary. The derivative of tan is sec square. The derivative of 7x squared is 14x. So what I just do here, I apply the, what is it called? Chain rule. So just go somewhere, go to the back of the book, differentiate y equals to tan 7x squared. By saying let 2 equals to 7x squared, you will get this 14x squared, 7x squared back. So that is what we just applied here. So thank you. Oh, sorry. Say to compare. Yeah. Oh, sorry. So sorry, from here now. Or if I differentiate tan 7x squared, that's a 14x sec squared, 7x squared, my bad. So change this part to sec square 7x squared sec square 7x squared. So that is how our answer will be. So practice the following question based on logarithm differentiation. Number 1, differentiate the following. Number 1, y equals to x cubed plus 2x multiplied by 6 plus 3x raised to power 4 all raised to power 4. Number 2, y equals to x raised to power ln x. Number 3, y equals to sine 4x all raised to power 6x. Number 4, y equals to 9 minus 3x all raised to power 10 divided by x squared sine 7x. Number 5, y equals to x raised to power cot x. So we've talked about differentiation and how to use a logarithm approach to simplify any form of difficult differentiation we were given. So in the next class, in the next video, we are going to talk about integration, which is known as an antiderivative. So thank you.